Hello, everyone, and welcome to Math with Mr. Gillis. I am your host, Mr. Gillis, and today we're going to be talking about areas of composite figures. Really, what you want to be able to do today is to find areas of composite figures by separating them into familiar figures. Okay, so to find the area of a composite figure, separate it into figures with areas you know how to find. Then find the sum of the areas of those figures. So for example, maybe you want to split it into a triangle and a rectangle, or a circle and a square, or whatever it might be. Just breaking up the pieces a little bit and then adding those pieces together. Let's look at what an example of that looks like. It wants us to find the area of this yellow figure. Okay, so the first step you should take in doing that is counting the number of full squares that you have. Okay, so like this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, so on and so forth, right? To find those full squares. And they already did it here for you in this first step. So the number of squares that lie entirely in the figure there's 45 full squares. But then we also have these squares that we only have a portion of them, and it lies actually right, it splits the square in half. So we count those portions, these little triangle portions, as a half, right? So we count those as half squares. 1, 2, 3, 4, 5. There are 5 of those that represent a half. Okay, so to find our area of the entire shape here, we would take 45, because there are 45 full squares, and we would need to add to that, we have 5 squares, and those are 5 half squares, so we need to take 5 times a half, which would give us half of 5 would be 2.5. So if we were to add 45 and 2.5, we would arrive at 47.5. And since there's no units on here, we would just say units squared. 47.5 units squared. Again, we're taking the full squares and we're adding the half squares to that. All right, go ahead and try example 1 and 2 here on your own. Do that in a similar fashion as we did the first one. All right. Here you have 1, 2, 3, 4, 5, 6, 7, 8. So 8 more is 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33 full squares. Okay, we have 33 full squares. And next I'm going to look at how many shapes that I have that are partial. Okay, so this one looks like it's a half. This one up here is a half. Okay, so that would give me another half, so that'd be 34. And you might be like, well, what does these, how much is this space here? How can I figure that out, or how can I calculate that? That's not exactly a half, right? So what I might encourage you to do is to, instead of counting them like that, break this shape down into 2 shapes that we know how to find. I purposely did that so that you can kind of see that that's not going to work for every method. If I were to split this shape right here, a lot of you are saying, yep, that's a triangle. I can figure out the area of this triangle. Remember the formula. Oh, that erased, darn it. the formula for a triangle, it's not going to be as accurate, but is the area of a triangle equals base times height divided by 2. Okay, so our base is 1, 2, 3, 4, 5. Times our height, this triangle is 1, 2, 3, 4, 5, 6 tall, divided by 2. Okay, 5 times 6 is 30, divided by 2 is 15. All right, so our triangle is 15 units squared. What about the area of this other portion? Well, this other portion just has full squares. We had 8 and 8, I think was 16, right? Plus these 6 would be 22. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Yes. So I had 22 full squares plus the 15 from the triangle will give me a total of 37. So there might be times when it's not splitting a square evenly in half, and you might have to use a formula like our area formula here. Okay, I'm going to erase here, and let's look at example 2 to look at some different ways that you could break up this shape here for the second on your own problem. Okay. All right. So, anybody have in this example? I'm not going to use a formula because I see these shapes right here are all half. They're all splitting a square in half. Same with these ones. You can count those as halves because they're splitting a square in half exactly. Okay, so you can count all of those. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can count those 10 as halves. So we have 10 times a half would give us 5. So when you add those together, you get 5. Now just add up all of your other full squares. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Okay, if I were to split this in half, this is the same as this, right? They're mirror images of each other. So if the bottom was 23, I'd add the top to that to give me 46 full squares, plus the 5 that were half to give me a total of 51 units squared. All right, so a couple different methods to do those problems. Let's move on and see another example. Example 2 says find the area of the portion of the basketball court shown. The figure is made up of a rectangle, so right here, and a semicircle, this portion right here, right at the top of the free throw line. Okay, so if we find the area of each figure and we add them together, that should give us the area of the basketball court. Just that specific area, I guess, okay? So remember, area of a rectangle is length times width. And the area of a semicircle is pi times radius squared. That's to find the area of the whole circle, and then divide by 2 to find just this half, because this blue portion is already calculated in the area of the rectangle. Okay, let's do that. Length times width would be, the length is 19 feet times 12 feet for my width, would give me 228 feet squared. And the semicircle, pi, so 3.14, times my radius. Okay, radius is half of the diameter. I know this entire length is 12, so half of that would be 6. So 6 squared divided by 2. Okay, a little plug and chug, 6 squared 36 times 3.14 divided by 2 should come up with about 56.52 feet squared for the semicircle. If I take and add the semicircle to the rectangle, should come up with 284.52. And remember, that's feet squared. Okay. Moving on to example 3, where we're finding another area of this composite figure made up of a triangle right here, a rectangle right here, and a parallelogram. So let's remember our formulas for each one of those. Triangle, I said it before, is area equals base times height divided by 2. Rectangle is area equals length times width. And a parallelogram, which is this shape right here, we have this side's parallel to this side, and the top and bottom are parallel as well. Kind of a similar formula, but we just call them different terms, base times height. All right, so let's break each one of these down, and then at the end, add them together and find their sum. Okay, so for the triangle, my base is 11.2 times my height is 4.5. So, and then divide by 2. I'm just going to round here. 11 times 5 would be 55. Half of that would be close to 25-ish. So plug and chug in the calculator. Should come up with 25.2. And that was close to our estimate. Rectangle. We'd have 8 times 4.5. Eight times 4 would be 32. 8 times a half would be 4. So 32 and 4 would give me 36 for the rectangle area. And then the parallelogram, my base is 8 times my height, which is, and again, height is a 90-degree, whatever creates this 90-degree angle with a parallelogram. So that would be 6.7 is the height here. And if I'm estimating 8 times 7 would be 56, so it should be close to that. Gives me 53.6. All right, so those are the 3 areas of the 3 different regions. Now to find the area of the entire figure, I add those. When you add them, you should get a sum of 114.8, and our label centimeters squared. Just a reminder, when you're adding decimals, make sure you're lining up your decimal points. All right, that does it for the examples. Please pause the video now and try the last 2 on your own problems. Alrighty, if you arrived at the correct answers for number 3, you should get 90 meters squared. And for number 4, about 10.28 feet squared. Okay, if you had questions on either one of those, let me know or phone a friend. As always, ask questions if you need more help, and I'll be glad to help. That wraps up 13.4, areas of composite figures, and that's the last section in chapter 13. So next up would be make sure you're studying for that test. Thanks for watching. I'll see you next time.